All right, I'm Rachel Oliver. I'm from the Air Force Institute of Technology in Dayton, Ohio. And this is our atmospheric propagation demonstration. All right, we start with a green laser over here, and it goes through a microscope objective, and a pinhole, which simulates a really small source of light, like you would see from a star in the sky. It spreads out from that pinhole source, goes through a lens, which collimates the light, making the beams nice and straight, which helps the light hit this beam splitter and spread in two different directions. The first direction it goes is down towards a second lens, which takes that light and then focuses it. So we can see that we're behind the focal point right now, so the light has spread back out. But we can bring this sheet of paper nice and close, and it gets smaller and smaller until you hit the focal point, and then starts to spread right back out. Now we can take a transparency, like this one that says SPIE, put it in front, so the letter is going right through the beam. Let's get this. Woo. To the S. All right. As it goes through the beam and those beams cross each other, the letter actually is upside down. And if you bring it past the focal point again, it flips back over because the beams haven't crossed yet. All right, I'm going to take this transparency out, and we're going to talk about the second direction here, where the laser light is focused down onto a CCD here, which is inside most cameras to collect light, and what we have in the back of our telescopes when we're taking imagery of the sky. All right. Now, ideally, if we were looking at the stars, we know that they're circular, and our images would be perfect circles like we have here. And you'd see the diffraction pattern on here, which those sort of diffraction patterns are showing the different wavelengths here, and we can actually use those for taking really precise measurements of small objects. But in this case, we have an ideal shape, which is not what we actually see when we look at the sky. When you look at the sky, you see a diamond and you see kind of twinkling happening, and that's because we have the atmosphere in the way. And the way that we kind of create this in such a small area to show it off, so we have this disc here with a mass of dirt on it, and we put it down in the way of the beam. And you'll see that the image itself elongates a little bit. Now, when we look at the atmosphere, it's not constant. It's thicker towards the horizons because you're looking through that larger cross-sectional area, and then it's constantly moving, and the dust inside of it's moving. So we can demonstrate that by turning our motor on, and it starts to rotate. So now we see what we would normally see when we look at the sky, a kind of diamond shape and that twinkling effect. Now, this is not ideal when you're trying to take a picture of something in orbit or in the sky. So there's a couple options to counteract this. We can take a video and then take all of the images, because a video is just a series of a large number of images in a short amount of time, put those images on top of each other, and then average out the attenuation error. And then finally, we can do a adaptive optic instead, and have a mirror that's controlled by a bunch of motors instead of having a solid lens that's constant, and change the focal point so that focal point's right on top of the CCD, so you have the most power going through that CCD and get a clear image. All right? Now let's talk about power and why you need to be really careful. This is a cool demonstration, but with kids, when I show it off, I wanted them to know that it can be a little dangerous to work with lasers. All right, so I have our nice little higher power laser, nothing crazy. I take a sheet of paper, I put it inside. Whoop. Let's sit there for a minute. Once it burns, it's going to take just a couple more seconds. There you go. You can come in nice and close, and you can see, especially on this side, that there's some burn marks on this piece of paper. And I tell the kids, you gotta be safe with lasers because it could hurt your eye, not just a piece of paper. All right, thank you.